Welcome to the first day of Algebra 2. We are going to review sections 1.1 to 1.3 today, going over applying properties of real numbers, evaluating expressions, and then also solving equations. So you'll need to have your notebook ready and prepare to write. We'll probably take up the first of one page and the back of that same page, and then we'll go ahead and do some problems tomorrow in class. So here we go. Alright, so the first topic we're going to look at is real numbers, and we worked on this in middle school as well as we've seen this in Algebra 1 and possibly in geometry. So we're going to just kind of review these real numbers real quick. So first thing, we're going to make a large box to encompass all of the real numbers and divide it into two parts. This smaller section is for the irrational numbers, and the larger section is for the rational numbers. Rational numbers, if you remember, can be fractions, decimals, repeating decimals, and terminating decimals, whereas irrational numbers are non-terminating and non-repeating decimals. Inside the rational numbers are these things called integers. Integers are positive and negative whole numbers. Inside the integers are the whole numbers, which are the numbers 0 through infinity, but they're all positive and they're all whole. And then the last set is natural, which is everything that the whole numbers had except for 0. So that's just kind of a quick re-explanation of the real numbers. So you want to make sure that you have that in your notebook. The symbols that we'll use most often are the symbol for real numbers looks like this. That means real numbers is like a double-legged R. And then the symbol for integers is like a Z that has two middle things, and so we'll use those two things most often. This means this is the real numbers and this is integers. Alright, so going on. Alright, we're going to do an example here that says graph, and we're going to graph -5/4 and the square root of 3 on a number line without using a calculator. Alright, so we're just going to think about things. So we're going to draw a number line. We're going to put 0, 1, 2, 3, 4, -1, -2, and -3. Alright, so we have those numbers. -1 or -5/4. So we can see that the top number is bigger than the bottom number, which means that this is more than 1. So 4 goes into 5 one time with 1 left over, which means we're going to go over -1 and then a little bit more. So it's about 1 1/4. The square root of 3, think about where it is on the number line. So think about all the square roots. So we have square root of 1, square root of 2, square root of 3, square root of 4, so on and so forth. Well, the square root of 1 is 1. The square root of 2 is a decimal. The square root of 3 is a decimal. And the square root of 4 is 2. So the square root of 3 is going to be somewhere between 1 and 2, but a little bit closer to 2. And that's all I'm expecting you to do on a problem like this. I don't want it in the exact place, which is why I don't want you to use your calculator. I just want you to think about where it is on a number line. Alright, so we're going to do a practice problem. And now we're going to look at the properties of real numbers. The properties of real numbers are interesting. We are going to look at the closure property, commutative, associative, identity, and inverse. So I'm just really wanting you to make a little table here. Alright, so we're going to make a table. The first column is going to say property. The second column is going to be for addition. So I'm just going to put plus sign. Third column is for multiplication. And then the last column will be an example. Alright, so the first one here is called the closure property. The closure property just means when you add two real numbers, you get a real number. So A plus B is real. And A times B is real. Alright, so an example would be like 2 times 3 equals 6. Or we could do 2 plus 3 equals 5. The next one is commutative. And it's commutative. And it is A plus B equals B plus A. Or we can do A times B equals B times A. And an example would be like 3 times 2 is the same thing as 2 times 3. The next one is associative. Associative is for grouping, so we're going to have parentheses A plus B, parentheses plus C equals, and then we'll have A plus, and this time the parentheses will move, the B plus C. Notice that they're still all A, B, and C. A, B, and C, the order didn't change, only the parentheses moved. So here again we have A times B times C is equal to A times B times C. So the order stays the same, but in this first one I'm going to group the second two, and in the second one I'm going to group the first two. So we get the same answer no matter how we group those, and that's associative. So an example would be like 2 times 3 times 4. If I multiply the 3 and 4 together to get 12, times 2 is 24, which is the same thing as 2 times 3 times 4. So if I multiply the 2 and the 3 together to get 6 times 4, I also get 24. Alright, the next to last one is identity. Identity is different for each of these. So identity, in order to retain the identity in addition, you have to add 0. In order to attain the identity in multiplication, you have to times by 1. But notice that in both cases you get A. So an example would be like 4 plus 0 equals 4. Or I could have done 4 times 1 equals 4. The next one is inverse. An inverse also is different for each of these. In addition, the inverse operation is subtraction, so you add a negative, which makes 0. In multiplication, the inverse operation is division, so you multiply by the reciprocal, which is like dividing, and you get 1. So in addition, you get 0. In multiplication, you get 1. So we'll do like 3. 3 times 1/3, so 3 times its reciprocal is 1. Alright, the last property is the distributive property, which we've used this quite a bit, I'm sure. So we're going to do A times B plus C. And remember, in the distributive property, you distribute multiplication to the first one, you distribute multiplication to the second one. So this would be A times B plus A times C. So an example of the distributive property is 4 times x plus 6 equals, so I take 4 times x and 4 times 6 to get 4x plus 24. Alright, now we're going to do unit analysis. On unit analysis, kind of like what we do in science class, we're going to work out this problem. We're going to travel 80 miles in 1.2 hours, and we want to know what was our speed. So if you're thinking in your head, speed, which is like distance divided by time, right? Rate of speed is distance divided by time. We need to take the distance and divide it by the time. I get 66.6 repeating, which is 2/3. We try to leave things in fraction form in Algebra 2 and not leave things in decimals or rounded decimals, just because we want to work with exact values, especially if we're planning on going into engineering or things like that. Alright, the next thing we're going to look at here is conversion. So again, very similar to science. I'm sure that you've done this before, but let's just go over it. So let's say that we have 350 feet, and I want to change that to yards. So the way I do this is I multiply by a fraction, and I know that feet has to go on the bottom because I want them to cancel out. And I know that yards goes on top because I want that to be left. And then I ask myself, okay, which one's smaller, feet or yards? And I know that feet's smaller, so he gets the number. There's 3 feet in a yard, and the yards gets a 1. The biggest one always seems to get a 1. So in this case, I'm going to multiply straight across. I'm going to get 350 over 3, and then I'll have yards. And I get 1/16 and 2/3 again. Alright, so pretty simple in terms of just writing that fraction and then figuring out how much is in each one. You can Google the conversion rates if you aren't familiar with them. Plus, you can also check your answers on Google, which is kind of nice. Let's do one more of those. Let's do 20 miles per hour and we want to go to feet per second. So we have to do a fraction for each of these. So I'll take care of miles first. So miles has to go on the bottom, and feet goes on top. And then to get rid of hours, hours has to go on top, and seconds has to go on the bottom because we want them to cancel out, so they have to be in the opposite side of the fraction. So there's 5,280 feet in a mile, and there's 3,600 seconds in an hour. And again, you can find that information on Google, or sometimes it's even in your agenda book. So we'll go ahead and just multiply straight across with the fraction. So I'm going to take 20 times 5,280, and then on the bottom, I'm just going to have 1 times 1 times 3,600. So I get 29 1/3. And that would be feet per second. Okay, so hopefully that makes sense, and if not, you can rewatch the video, or you can come in and ask questions. The last thing that we're going to do, that I'm going to show you how to do, the other part that'll be in your assignment is evaluating expressions and combining like terms, which is something I feel you probably have a good grasp on once you reach Algebra 2. Let's go to solving equations. So we're going to start with 5b minus 8 equals 12. So remember, again, the goal is to get the variable by itself. So we're just going to add 8 to both sides. We always get rid of the minus or plus part. So I have 5b equals, and this makes 20. And then divide both sides by 5, and we get b is equal to 4. So let's do another one of those. Let's do 4/5 x, 4/15 x, plus 6 equals 5. A little bit harder problem, but again, you start the same. Get rid of any addition or subtraction that's on the same side of the variable. We have 4/15 x equals, and this will be -1. And then remember how to get rid of a fraction. You multiply by the reciprocal. So I'm going to multiply by 15/4. So these guys will cancel, which is nice of them. So I have x equals -15/4. And in Algebra 2, we just leave things as improper fractions. We don't want to turn it into a decimal. It's fine just like that. All right, and the last one is where we have variables on both sides. So I'm going to have 6x plus 4 equals 9x minus 12. So I'm going to get the variables on the same side. So I'm going to minus 9x minus 9x. So that's going to give me -3x plus 4 equals 12. Right, now we're going to do -4 minus 4. I'm going to have -3x equals 8, and then divide by -3, and x is equal to -8/3. Right, so we'll do an example of those, and then you get to do an example as well. So exciting. All right, and now the best part is for our homework assignment. Since you're new to maybe a flipped classroom, you will know that the homework is actually done in the class. So watching the video is actually your homework, and then we will work in class to do additional problems, so that way if you get stuck or whatever, I'm there to help you, which is kind of cool. So hopefully you took notes, because with this new program, fortunately I'll get to know. So I'll see you tomorrow in class. Thanks.